Awesome.
Unlike everyone else here who made a game, we decided to make a Pokédex app we call Rustex. So this works. This is your home screen, and you can click on any of these.
Who's we? I missed your names.
Oh, I'm Scott, by the way.
I'm Robert.
So if you click on any number in this list, and click catch them all, it will load the sprite of that and load the name, dex entry, count, height, stuff like that. And the way this works is it queries a Postgres database that we populate before this program even runs. So this program can work offline. See right there. And what's interesting is that we use a crate called R2D2 to create a connection pool that we can use to share across threads. Because without threads, they'll request to the RESTful API will just go incredibly slow. So we split that work across threads, use all those threads to populate the Postgres database so we can fetch the results really quickly. And yeah, that's pretty much it.
Cool. Nice. What framework are you using?
What we're using Relay.
Oh, cool.
Relay, I think that's how you pronounce it.
It's French.
Yeah. And you kind of have to put Relay in Rust language, or otherwise you get a bunch of French dishes. Kind of interesting. But we use that because it was a tiny HTTPS framework, and
very,
it
very
didn't
simple, and mostly what you're doing is queries.
Yeah, didn't really want to go rocket and
Yeah.
constantly switch nightly and back and forth, and then too much.
Really
work.
cool.
Yeah.
So are you using like the basic Pokédex, or do you include all of the weird types you can now catch in Pokemon Go?
It can catalog every single Pokemon.
And is it cataloging like the entire Pokédex or Pokemon that you have?
It's cataloging the entire Pokedex.
Ah,
We can make it catalog the entire Pokedex, but that will take way too long.
right.
It'll take probably like 10 seconds to populate the whole entire database as opposed to like 2. So yeah.
Cool.
How hard was it to implement Postgres with Rust? Library with your cargo package you have to use?
Well, surprisingly, it was really easy to implement Postgres with Rust because Postgres actually has, or Rust has a crate that's literally called Postgres.
You could have used
Like
Diesel,
C.
which is much harder, but gives you some benefits. But for what you're doing, just using the Postgres crate is perfectly reasonable.
Yeah, the hardest part was actually learning how to use Relay and learning about Git and post requests. Yeah.
Was your project an inspiration of a previous Carla program?
Kind of.
I may or may not have been in that class.
Cool. Did she assign something like that?
Yeah. It sounds like something you would do.
But she presumably didn't have people querying web APIs for
No,
Pokemon and
no.
storing in their Postgres database.
No, it was like, I think it was entirely like a text document or whatever. So.
Yeah. Cool. Very, very cool.
Yeah.
So we are a 3-person team. I am Robin Gurd,
I'm James Westcott.
and the third person is not a member of the class, but that's my husband, Tim Westcott, who is our embedded hardware engineer, who happened to have lying around this ST32F3 family discovery board that has a little ARM processor on it, and they have like an accelerometer, magnometer, as well as user button and LEDs. And what you're seeing here is a version of Blinky, and in the embedded world, Blinky is Hello World.
Yes.
And we started, can you go to the website there? We started by looking at the embedded book, but then we found out that this embedded discovery board, if you go to the Git website. Your thing is just showing X links. We went, so the embedded GitHub, they have the embedded book there, but they also have something called Discovery. And it is a tutorial walking you through projects to run on this specific discovery board. And it was incredibly useful for someone who had never done embedded systems before. And it starts with a version of this. We then added in a simple program that operated buttons. And then James implemented some timer code. So their code basically just does delay. It just sits there, you do something, and then you delay for a certain amount of milliseconds. But we wanted to do this different thing. So at this point, it turns on an LED, and it's checking, do I need to turn on an LED? Do I need to turn off an LED? And so it can't sit and delay. So this was one code. And then to flash the stuff, you have something called OCD, open on one terminal. And then you basically open something on GDB, and on a GDB that is designed to run this code, and it loads the code onto this. Can you load to button?
And the exact GDB command will vary based on your system's Ubuntu commands are something like GDB multi-arch. For Arch, it is R9 EV GDB, and we want it to button. And I did fancy things in my GDB.
Am I flashed?
Yep.
Okay, so two button, So this is the original board, and this is the user button, and the user button, each time I press it, I started with just this code. I just have a one button thing that just, each time it goes around, turns them on, turns them off. But then we created a second button that goes on a different set of pins, and it runs the buzzer right here as long as we press. And then James is working on a timer function, but it doesn't quite work yet. So, any questions? Well, I think he's going to try running the timer function.
What would you know, like the major differences as far as like memory space and all that kind of stuff between C and Rust when doing embedded?
I saw a Facebook post on this recently, and C is a little bit more than Rust. Takes a little bit less memory space than Rust. But they're really pretty close. They were like both up at the top. But in a chip like this, it's just not a problem.
Right.
There's just so much memory space.
Right.
We've got, I think, 8 kilobytes of RAM.
So
And compared to, Dad's first computer, which had 256 bytes.
The reason that my husband was here and helping is he does embedded systems work, and he's looking at switching to Rust, and so that's why he threw us to the wolves.
Yeah.
Any other questions?
So tell them how much that board costs, that discovery boards. If you want to play, how much would it cost?
It's about $16.
Yeah.
This one was free. It was lying around the shop.
They're about $16.
They're about
So
$16.
If you're interested in doing embedded, buy that exact board off DigiKey.
Yeah.
And
Yes.
go to the embedded Rust book and
Or
go through the exercises.
Better
It's kinda
yet,
awesome.
if you're not used to embedded, do the discovery book.
Yeah,
That's what I'm saying.
it's not the embedded book, 'cause the embedded book itself assumes some knowledge of embedded systems programming, and it just leaves you pounding your head. So it's the discovery, it's in the same
There is a
GitHub
book
thing.
written specifically with a bunch of exercises on this specific board, and you can buy that board for about $16 if you want to play embedded programmer. Who's up next, by the way?
And so this
Where are they?
would
next
be
up
the
person?
timer if it were. I flashed it. I swear I flashed it. Well, this stuff happens.
Very nice. Interrupt handlers are hard. Look at
No
it.
interrupts.
Oh, well, what, you said you were starting a timer. Is the timer?
I'm
It
just
just pulls.
pulling it.
It just
Oh.
pulls.
Okay.
Cool project.
I'm Lane,
I'm Andre.
and our project is called Games Closet, which was, when we started, an optimistic attempt to do multiple basic games that evolved into a focus mostly on implementation of Connect 4, which has been set up with a framework from GG Easy's Crate. And so we just basically set up with the main menu, giving the options to, again, select a game, which is really just an option now, pick the number of players, because we added a AI implementation in case you wanted to play against a poorly crafted bot. So, yeah, we just pick one of the options, and also the menu populates, so like if you were to click away from one and click it again, it disables options and back up, do things like that. But we'll go into a game. And so that's the UI. You have your little token at the top, and the AI player's turn is now, so they'll be picking. You can go and click debugging information, you can see running the terminal down below. Also gives you clear where you're going.
Yeah, the AI is kind of slow because the delay is based on frames.
Yeah, it's based on, so like GG Easy calls the draw and update event periodically to just render the things and then do any game logic. And so you can set up some timing function, but we just based it on the number of iterations. So it's pausing a little bit just to like let you know, hey, this is where the AI is going, because otherwise it goes so rapidly you may not even see where the tile is placed. You're not paying attention.
I'm just gonna reset,
Yes.
just resets the board. And if I press main menu, we can go back. This one goes AI versus AI. Just kind of slow.
Yeah, and it does a really weird pattern.
Yeah, it always goes through the same pattern. I guess the probability, because we take max.
Yeah, so it's
So they
looking,
always-
it's basically recursively looking for like the best move by looking ahead and trying to see if a move would either give it the win or on an opponent's turn if it would give it a loss and try to avoid that kind of move. Obviously, it's not perfectly implemented, but it actually was kind of entertaining to play when you're playing multiplayer mode.
And just showing normal win condition, then we cannot do anything on the board. So we have to reset. So,
Very cool.
and if the board is filled,
It's a draw.
it's a draw.
Yeah, the draw stage.
So a player wins if they fill up an entire column with their color.
So,
No,
Connect
four
Four
in a row.
either horizontally, vertically, or diagonal.
Yeah.
Yeah, this is our spec.
Classic.
Cool.
Cool. Anybody left? I see no anybody's left. All right. Cool. Well, questions for these folks? You are aware, right, that Connect 4 is perfectly solved, right?
And there's a way to
I
get
met the
draw.
guy and played against his program once that plays perfect, unbeatable Connect 4, which is kind of interesting.
It's either win or draw, I think.
It's a first player win.
Oh, really?
That's not a practical thing to create a program. It's fairly hairy even today. But you can improve your evaluation function a little bit. The typical thing to do is instead of just looking for wins and losses, you actually score, failing that, you score the length of rows that you've made and that they've made, right? So you give yourself points for the rows of 3 that are in, and them points for, they give them points for rows of 3 too. And so if you build just a little fancier evaluation function, you're looking at it to get very strong. Yeah, if you want that.
By the way, did you build the 0 player in reference to war games?
No, it was just a representation of how many human players.
Yeah, definitely a little tweak to your code to speed up in that mode fairly substantially.
There's lots of things.
Yeah, a lot of things. That's cool. It's really cool. Very nice implementation. Very cool. Very cool. It's over.
we're done with this thing. We got 5 more minutes of class, and then it's just, you know, obviously people still need to get their open source visit in tonight if they're gonna do it, or tomorrow night, or Friday night or something. The game jam is still on. We have one submission already, and it's actually pretty cool. It set the bar pretty cool, plus I have a sample submission up. I imagine most of you won't even look at that until after tomorrow night, and that's fine. That's well within the low effort theme, but I would encourage you to look at it, because it's been kind of fun so far. I really like the game that's turned in. The projects, obviously, I'm gonna clone them sometime tomorrow night or the day after, and so please have your master branch be what you want to grade. Based on what I've seen today, if everything's this cool, we're all in really good shape. I'm really very happy. Thank you to everybody who presented today. I mean, the thing I always say at the end, and I really mean it, is first of all, I'm not going anyplace. I plan to be in town through September, and then in the fall, I'll still be here doing stuff. Don't feel like because the course is over, you can't, you know, I'll leave the Slack channel up, and try to watch it to some extent. You know, you know what my email is, you know where I live office-wise. Don't hesitate as you go forward doing Rust stuff or anything else to ask for, you know, ask me. I'm happy to still be a resource. The other thing I always say, and this is always probably as good a place to close as any, is thank you. Thank you, especially the people who are in this room, most of whom I think have been in this room 20 times now, or thereabouts, for, you know, sort of sticking with it and figuring it out and being really, really fun people to play with. I always have a good time with this course, and this was one of the best ever, so thank you very much. Yeah, question?
What courses are you teaching in the fall?
Capstone and CS 251. So there you go. If you're in Capstone, I'll probably see you there. If not, then probably not. I probably will teach an elective in 2 electives again in spring. I'm not sure when I'll
Will you continue teaching this course?
Oh yeah, whenever I get an opportunity.
Does anybody else you guys can teach Rust courses? Or like,
No, nobody else really programmed it except me as far as I know. Cool. Very, very cool. Well, thank you all. I will see you around.